prove that the Laplace of this is this, correct? So let's start with the fact that the Laplace of e to the minus at is nothing but 1 over p plus a, yeah? And the Laplace, similarly, the Laplace minus vt is 1 over b. You agree? Okay. So that just means that the Laplace of if I put these two together, and Laplace, you could add them. So e to the minus vt is nothing but over p plus b. Now the only problem is I'm still missing the t in my expression. So then what we're gonna say, we're gonna call this g of t, and we're gonna say that the Laplace of g of t over t, as long as t is integrable, right, is the integral from p to infinity of the Laplace of this, right, which this guy here. So that's 1 over p plus a, right, because that's the Laplace, 1 over p plus b, well, we're supposed to use u. Let's use u so we can that basically match the table, yeah? U plus b. So I'm replacing p with u for the sake of a dummy variable integration. And this would be du. Okay, that's L31 in the table of Laplace. And now we can go ahead and integrate this. Yeah? So then the Laplace of g of t over t would continue to be ln of u plus a absolute value, because the integral of 1 over u plus a is ln u plus a du minus ln of u plus b absolute value from p to t, and when we are done we will take the limit as t. Let's use some different letter than t because t is reserved for it. Let's use or q, as q goes to infinity. Okay, okay, so now let's go ahead and evaluate this integral. So this becomes ln q plus a. First I can put them into one log, yeah? Yeah. So this becomes ln u plus a over ln u plus b. And I will evaluate from p. I don't like this q, let me call it k. I'm gonna call it k, okay? So, and then we will take the limit as k goes to infinity, so p to k. And then if I evaluate this, I will get ln k plus a over k plus b minus ln u plus p, or instead of u, I'm plugging in p, so p plus a over p plus b Okay. Okay, and then we will take the limit as k goes to infinity. So on the first one, we will get ln infinity over infinity. So we can use L'Hopital's rule, or we could divide by k. Either way, it's fine. So if we do that, we would get minus ln p plus a over p plus b. And so, or you could use L'Hopital's, yeah. So you could take the derivative of this, so that's 1 over 1. And then you have here ln1. And then you take as k goes to infinity. Well, there's no more limit. There's no more k. So the answer is just ln1, which is 0, minus ln. Now I could flip these two, so I can get the answer in the table. P plus b over p plus a at a cost of a minus sign here, yeah? But by the properties of the logs, I can make this minus sign dive here. And minus and a minus will give me a plus. And so the answer for the Laplace, for this Laplace of g of t, which is actually e to the minus at minus e to the minus bt over t, turns out to be plus ln p plus b over, which is exactly what you see in the table in L21. Reads the proof. You see? Or no? Any questions now?
It's mostly